Earth, a unique planet like no other in the vastness of space, with complex ecosystems teeming with life and biodiversity. But there are places on Earth that are so extreme, making it seemingly impossible for life to exist there, reaching extreme conditions from intense heat to freezing cold, places with nearly no water to complete salt deserts, and even highly acidic places that would be fatal to most life forms. But some organisms have evolved to not only survive but thrive in environments once thought to be entirely uninhabitable. These organisms are called extremophiles, which translates to lovers of extremes, because these organisms have the ability to thrive in extreme environments, such as hydrothermal vents. While most extremophiles are microscopic organisms belonging to a domain of life known as archaea, they do occur in all three domains of life: bacteria, eukaryote, and as just mentioned, archaea. Extremophiles have continued to thrive in environments once considered uninhabitable, from hyperthermophiles in boiling hot deep-sea volcanoes to psychrophiles in the freezing waters of Antarctica, and others even in places with high levels of toxicity and radiation, making them one of the most abundant life forms on Earth. But the most extreme living things on our planet are tardigrades. Technically more extremotolerant than extremophilic, these 8-legged microscopic creatures are one of the most resilient organisms known, because they are polyextremophile, which means that they can survive under multiple harsh conditions. They are also known as water bears, because of their adorable miniature bear-like appearance. But despite looking squishy, tardigrades are covered in a tough cuticle, similar to the exoskeletons of grasshoppers, or other insects to which they are related. They have been to outer space and would likely survive the apocalypse. Their resilience is in part due to a unique protein in their bodies that protects their DNA from being harmed by things like ionizing radiation, which is present in soil, water, and vegetation. Besides that, they have two strategies for surviving in extreme environments. In case of flooding, these microscopic animals can inflate themselves like balloons, allowing them to float up to the surface, where they have access to oxygen. But probably the more interesting strategy comes to play in the case of drought or freezing conditions, because these little animals have a remarkable ability called cryptobiosis, which makes them one of the hardiest organisms known. They can replace more than 97% of the water in their bodies with a type of sugar called trehalose. This reduces the need for water and prevents ice crystals from forming that would otherwise form within water and harm these organisms. They then retract their heads and limbs and roll up into a little ball and become dormant, allowing them to survive these conditions for decades. When their conditions improve, they unfurl themselves and go about their business. Using these survival techniques, these creatures have survived temperatures from -458 degrees Fahrenheit to 304 degrees Fahrenheit. Pressures 6 times greater than those found in the deepest parts of the ocean, lethal doses of radiation, and even the vacuum of space. Still, the longer tardigrades stay in non-optimal conditions, the lower their chances of survival. Extremophiles are of great medical and biotechnological interest, as they produce enzymes, so-called extremozymes, that allow them to function in such forbidding environments. This could make them useful in industrial production procedures and research applications, due to their ability to remain active under the severe conditions typically employed in these processes, or for developing genetically based medications. For example, they are already being used to protect people from exposure to UV radiation. The study of extremophiles also provides an understanding of the physiochemical parameters defining life on Earth, and may provide insight into how life on Earth originated. These extremophiles may have a lot in common with the first organisms to appear on Earth billions of years ago. If so, they can give us insight into how life on our planet may have arisen. That's why astrobiologists have also taken interest in extremophiles, in their case for their remarkable resilience in freezing environments. Extremophiles, or in this case psychrophiles, that are active in such cold environments, raise the possibility of life on other planets, as the majority of bodies in the solar system are frozen. Additionally, the biochemical properties of such psychrophiles, such as the ability to use arsenic rather than phosphorus for their growth, furthers the possibility of extraterrestrial life, since extraterrestrial environments may favor life forms that use or are built from elements not typically found in life on Earth. And because extremophiles live on extreme ends of the spectrum, they can indicate the range of conditions under which life is possible, providing scientists with clues about where and how to search for life on other solar bodies. If you enjoyed this video and want to see more, please leave a like and subscribe to support the channel.